Hello, welcome to PrestoCon. It's really great to see you all virtually here, and to see even the West Coast early hours, to see the number of attendees that have logged in. So thank you and good morning. Allow me to introduce myself. I'm Tim Meehan, and I'm a software engineer at Facebook. I've been at Facebook for about 2.5 years working on Presto. My focus lately has been on reliability and scalability, in particular, coordinator scalability and better resource management. Okay, so let's get started. I'd like to kick this off by giving a quick background on what Presto is. If you've been to past PrestoCons, you probably have a really good idea, but some people may be new, and the good news is it's relatively easy to describe in one slide. So Presto is a distributed query engine that accesses data in place through pluggable connectors. That sentence is kind of like, I think, encapsulates a lot. So let's deconstruct it just a little bit. So firstly, Presto is open source. The entire Presto engine is available to view publicly on GitHub, and we welcome and encourage external contributions and try to make customizations easy through certain design techniques, which I'll describe later. Presto is a distributed system. So this means that many different processes are being orchestrated and run in parallel to perform an operation that would be infeasible for a single process. So Presto is designed to be scaled up and down according to the needs of the operator running Presto, and Presto provides metrics and information that allow operators supporting Presto to understand the performance and operations, even though it's a large distributed system. Presto is called a query engine because its API is the query, not some other structure like, let's say, JSON or data frames. So the primary interface that you work with in Presto is the SQL language. You give it a SQL query, you give Presto a SQL query. Presto translates this into a program which is distributed across its worker fleet, which all work in concert to give you a single consistent answer back. So that's what we mean by query engine. And then that accesses data through pluggable connectors. Presto allows you to introduce your own plugins that interact with the core Presto engine without having to touch the engine itself. So these are called connectors and allow you to serve data from almost anything, from HDFS to thrift servers, local files, relational databases, log systems like Kafka. It's very flexible. And where you put your data so that you don't need to needlessly ETL the data before you get it. You have a lot of flexibility on how you can store it without having to ETL it over and over again, depending on which data source you want to serve it from. So what makes Presto different? To my mind, that also boils down to 3 different areas. Number 1, Presto is built to be scalable. You can add workers to meet your needs and grow with your data. The second one is pluggable connectors. So Presto allows you to plug in new data sources. Even if the data source doesn't exist, it's not a major lift to write your own. You don't have to interact with the core engine. There's a pluggable interface for you to implement to make your own. And number 3, Presto is built with performance in mind, though, as I'll mention later, we keep improving the performance. It's pretty much a never-ending journey. So if you're here at PrestoCon, I imagine you're here because you love Presto and you want to learn more about the latest updates. So that's what I'm here to talk about. What's the technical state of things with Presto, and what do we have to look forward to as well? And so this is kind of like also talking about why we love Presto. Like we're building things that we love about Presto and making them even better. So to my mind, all the reasons why we love Presto boils down to 6 different areas. Number 1, it's fast. So Presto is really fast. It gives you the data quickly and with low latency. And as we'll see later, we keep on improving that. Number 2, Presto is efficient. So it's not only fast, but it also delivers the data with efficient usage of CPU and memory and resources that you may be paying for on the cloud, or that may be constrained in your organization. Number 3, Presto is designed to be reliable and to be reliably scaled up and down without affecting the reliability of the entire cluster. Number 4, Presto is standards compliant. So the SQL syntax that Presto uses strives for ANSI SQL standards compliance, and we do not create our own query language with custom special semantics. We strive for ANSI SQL compliance. If you've used Postgres, you'll feel very much at home with Presto. And it has a vibrant community. So Presto has a large and growing community, and we'll talk about that later. But that's, I think, one of the reasons why we all love Presto. So now that we've talked about why we're here, and why we love Presto, and why we're here at PrestoCon, I'd love to share what we've accomplished and what we're working on. This isn't comprehensive. This is just basically a few select highlights. But I feel like this is like all this is going to be a pretty good update for folks. And naturally, this ties back into all the reasons that we love Presto. So let's get started. You may have heard in the past about the Raptor connector. The Raptor connector co-located the Presto worker with work data that resided in local flash. And as we talked about last year in the last PrestoCon, the Raptor connector is fast, but it's challenging to scale because the size of your data is essentially tied to the number of compute-heavy machines that you could buy that also had high-performance flash drives. So it's essentially tied the compute with the storage, which leads to scaling challenges as storage needs grow and grow and grow. So RaptorX disaggregates the storage from the compute by using remote storage, but leverages local caching to compensate for the lack of co-located data. So using a hierarchical cache, we're able to beat the performance of Raptor while also gaining the flexibility of allowing the storage to grow as large as it needs to be. And the side benefit is that there's no need to ETL the data either, unlike Raptor. You simply enable RaptorX in your cluster and you reap the performance benefits. So this feature is ready to use right now. As Deepti mentioned, please go be sure to check out the talk from James Sun, who will talk about this in depth. But we're really excited about this feature, and we really love this internally at Facebook. Another way that Presto got faster is the introduction of dynamic filtering. So dynamic filtering is an optimization where you imagine the build side of a hash join as a filter. So by collecting the build side first and replacing this as a filter, you can push that filter all the way down into the larger probe side. This is the side where we scan all the data and then use it to do a hash lookup for hash join. And by doing that, you save a lot of data that needs to be shuffled and processed later. So in production workloads that take advantage of it, we found that we saw an up to 80% latency improvement and even higher CPU improvement as well. So we're also very excited about this feature, and it's done and it's ready to use. You just need to be using a broadcast or a co-located join in case of grouped execution. So now let's look at a really cool way that we're improving latency in the future. Currently, Presto supports list and hash partitioning. List partitioning is familiar Hive partitioning, and then hash partitioning is essentially grouped execution or bucketed execution. Zero-order partitioning is a new partitioning scheme that clusters the data along multiple axes and allows for partition pruning along those multiple axes with a much higher filter rate than can be achieved from feasibly achieved in the average case by either of those two methods. So we're also very excited about this feature. It's upcoming and the work is being planned, but stay tuned for more details about this. Let's move on to efficiency. So let's look at all the ways that Presto efficiency improved. Presto has now introduced a purely binary transportation protocol for communication between workers and the coordinator, and this is written in Thrift. We found that by moving away from JSON, yes, this was JSON in the past, and onto a purely Thrift binary serialization, we improved the CPU utilization on the coordinators by 8%, and also reduced the CPU on the workers by 2 to 3%. And that 8% savings on the coordinator leaves more room for scaling the cluster to get even larger and reducing the hardware requirements on the coordinator, which can be significant. And best of all, this is already available. All you need to do is update your Presto version. Let's also talk about more efficiency improvements. This is a big one. Last year we talked about Project Aria, which had the goal of implementing major performance optimizations for the top operators in Presto, including scan and repartitioning. On top of the already announced 10 to 20% improvement from the initial project, we landed another 2 to 8% of CPU improvements with further performance optimizations. This was simply better software engineering. By leveraging mechanical sympathy, or in other words, coding in ways that are CPU friendly, we were able to decrease CPU utilization quite a bit. And I'd like to give a quick shout out for Ying Su for these amazing enhancements. And it's available now. All you need to do is opt into Aria. There's instructions on how to do that at the end of this presentation. Let's also talk about Parquet efficiency. So we improved Parquet by making performance enhancements in the writer and by leveraging projection pushdown for complex types like list maps and the like. So these are already done, but in addition to that, we also are working on implementing Aria for Parquet, which will further improve the performance by leveraging all of those wonderful performance enhancements that we get by using Aria, including complex filter pushdown, filter reordering, and the like that we've already discussed. So be on the lookout for that as well. We spoke last year about a native engine which is being developed. Creating a native engine that plugs into Presto has numerous advantages. Firstly, you get better vectorization or usage of SIMD instructions for better performance. You get better control over memory usage by having basically direct control over the memory that's not possible to, or feasible in the JVM. And you also get to remove the fixed overhead of the JVM, including garbage collection, by leveraging a native worker. And in addition to that, by factoring this out into a library, we are able to leverage the execution in more components, including things like Spark. So we're very excited about this native engine, and we expect to see truly great performance improvements. As you can imagine, this is a massive undertaking, and we hope to have an update to share later this year on this. So let's now talk about reliability. We talked last year about Presto on Spark, whose goal was to leverage Spark to run Presto queries that have either extremely high memory usage or very long duration, or hit issues with local shuffle scalability, things of that nature. The idea is to leverage Spark to move into the very large-scale batch ETL while keeping the Presto syntax. So we shared last year that 80% of query shapes were supported, and now we're excited to share that 100% of query shapes are now supported by Presto on Spark. The same query can now organically move from interactive to massive batch scale, and you can leverage your existing Spark deployments to accomplish this. And we're very excited about this because what this means is that you can use the exact same Presto syntax to prototype and to perform data exploration, and then move this onto batch without having to do a rewrite in case that the scale of the data is truly massive. So it's now with 100% query support. It's still beta though. Please, if you experience any issues, reach out to us on Slack or on the Presto issues. But please give this a feature and try and let us know how it works. We're very excited about this feature. So let's talk more about reliability. Last year we focused on improve the gaps in spilling and allowing it to be more flexible about where spilling occurs. So if you have a temporary storage service or a place that's optimized for spilling, you can now leverage that in Presto. We also fixed up the join spilling and added additional spilling support and flexibility in how spilling is decided, so that it can be more tuned according to your use case and leads to less results where the cluster memory, cluster utilization is slow because of excessive spilling by several queries in the cluster. This will reduce local OOMs and allow Presto to run more reliability with less failures. And these features are ready to go in the latest Presto release. Last year, we also talked about an initiative to introduce multiple coordinators to Presto clusters. We tweaked the design to improve its reliability and suitability for cloud deployments, and which will allow it to scale to larger cluster sizes and remove entirely the coordinator as a single point of failure, and allow the coordinator pool to scale independently of the worker pool size. So this is a critical project within Facebook, and we're thoroughly testing this feature now and hope to have an update for the community soon. And Swapnil Taylor will be giving a talk later on this, and I encourage you to check it out. We're also working on better resource placement within the cluster. So we're working on allowing Presto to have knowledge about which nodes are overloaded or which have high memory utilization, so that we can distribute the load evenly within the cluster. We have very encouraging early results with this, and we hope to share updates soon. But yeah, please stay tuned for that. Cool. So let's now move on to extendability. Within the last year, now Presto supports SQL functions. Here's an example of the syntax. But what you can now do is you can compose complex expressions in Presto inside a function, and you can use this to function. You can share this function with colleagues or share it in pipelines without having to essentially repeat the same expressions over and over and over again. And so this is available now. Please see the open source documentation on this. Please give it a try if this interests you. And of course, any talk about extendability would be incomplete without mentioning connectors. So I'd like to highlight two new connectors which were added. There's the Druid connector, which is running in production at Twitter. Please give it a try. And the Oracle connector was added as well. Please give this a try if you use Oracle, and you'll find this useful. We also have several more coming along the way. So firstly is the Iceberg connector, which is going to be described later today. That's something that we're very excited about, and it's going to be helpful, I think, for a lot of different folks. We'll also have the Prometheus connector, BigQuery connectors as well. There's going to be a talk on that, and then also arranger support for security. And in addition to SQL functions, we're also working on external functions via pluggable function servers. So similar to how the Thrift connector allows you to create a Thrift server to serve as a data connector, you'll now be able to create a Thrift server that will serve external functions to Presto. You can think of particular functions that only exist in C++ or Python, or things that you'd rather not recreate in Java, or things that are impossible to recreate, or things that you would like to prefer to offload to an external process. External function server can accommodate all of these use cases. Technically, this is in alpha, but you can give it a try. Some bugs need to be worked out, and bug reports are always welcome. Cool. So the last thing that we were talking about why we love Presto is the open source community. We love the big, vibrant community. So let's look at some of the open source statistics over the past year. Over the past year, we've had 1.7 thousand new commits, 500 new forks, 1.5 thousand new stars, and we've had 16 open source releases, so major releases. So I'm really happy about these numbers, and I'm really grateful for everyone in the open source community that helps contributing and keeps pushing this project forward. These are really great numbers, but the question I would like to ask is, how do we make all of this 10 times better? So what are we going to do to get to 10 times the commits and 10 times the forks and 10 times the the contributors contributing to Presto? And so like that's kind of like what this conference is about. I'll highlight a few things, but I'll also be mentioning other talks later today that you should definitely check out. You know, like all of this really ties back into what are we doing to make, you know, all the things that we love about Presto, what are we doing to make those even better? So firstly, we're going to make Presto even faster. We're going to be pushing towards even more low latency and high QPS use cases. We want to do this through a lot of areas, including improving the bottlenecks in all areas of the stack, improving our ability to do intelligent partition pruning and data clustering to allow for very quick reads. RaptorX also is really a critical component in getting us into this very low latency space, and expect more work from this in the future that James will talk about. We also are looking at the pre-aggregation space with support for materialized views, and also connectors like Pinot, which Zhang will also talk about, help move us in this direction. So we want to make Presto suitable for even faster use cases. We want to make Presto even more efficient. And so really the native execution engine is going to be foundational in getting us there. Definitely stay tuned for updates in this. We also have other improvements, including end-to-end binary and further improvements in the algorithms that we use for all of our operators. So continue to stay tuned. We want to make Presto even more reliable, including durability in challenging environments. So we want to add the ability to allow dynamic and failure-free scaling, allowing one to leverage elastic resources without noticeable error increases for users, expand Presto clusters without reasoning about coordinator utilization, and continue to use Presto large batch mode and Presto Spark for the extremely large end where queries that benefit from the reliability of Spark for these large ETL type of queries. And then also work towards a partial recovery solution that is more suitable for medium to short queries. So keep an eye out for all of that. We want to make Presto even more extendable. So we want to keep on adding connectors, and we want to keep on supporting these connectors from the community. We want to bring external function support, like to the whole open source ecosystem, and allow the open source ecosystem to run with that. And there's going to be talks about Iceberg and Hootie that also move us toward this, very scalable future of metadata architecture. And we also want to make the core SQL functionality a library that will allow it to be embedded into other processes, so that we can leverage the SQL syntax without any change in syntax or semantics. But the most important thing actually is going to be everyone who's in this talk and everyone who's attending this conference. So there's many different ways to contribute, and your participation is actually what makes this project successful. So in particular, please join our Slack group. Please feel free to ping that group for any questions, any comments, questions about its operations, questions about its design, anything that comes to mind. You can file issues for missing functionality or ideas that you have for Presto and GitHub issues. But probably feel free to ping the Slack group before that. Take open issues and offer to work on them. There's many different open issues, and I think that there's something for everyone. If you're looking to contribute at a code level, there's many tasks that are of varying difficulty. Feel free to look through some of the open issues or ask for help for suggestions. Contribute blog posts for your Presto use case. We know that there's a lot of Presto use cases out there, and each one of them is unique. Sharing this experience helps others in the community, understand how others do it, which is really helpful, I think. And you can also, contribute a bug fix, a connector, kind of like as I mentioned earlier. And also try out the new features. So if very low latency queries interest you, give RaptorX a try. I've linked to a bullet here about how to get started with that. If you like the idea of scaling your interactive query all the way to massive batch scale, give Presto on Spark a try or Presto Unlimited. If you like the performance benefits on Orc and soon to be Parquet, there's instructions on how to get started with Aria. Be sure to, update Presto to use the latest Parquet improvements, and so on and so forth. And I would like to end this just by saying thank you. I appreciate, everyone being here, and I hope that you enjoy your session and get a lot out of it. So thank you.